Hey guys, so here we're going to take a look through a cheeky little proof involving prime numbers. Now I get asked quite a lot by my minions, are there an infinite number of primes? Now the answer to that is probably quite counterintuitive. Yes, there are an infinite number of primes, which they always struggle to believe me when I tell them, which I understand fully, still baffles me a little bit. You would think the bigger a number gets, surely something less than it has to divide it by the time you get to something with a ridiculous amount of digits. But no, not true. So we're going to take a look at how to prove there is an infinite number of primes. So first of all, remember that a prime number is a number that is only divisible by 1 and itself. So 2, 3, 5, 7, 11, for example, they are all prime numbers. The first important bit of information that we need to take through with us is to recognise that every number is either prime or not prime. Okay, it only has two options. Now then, first of all, what's the biggest prime number that we know of at the moment? So filming this in July 2017, the biggest prime number that we know of so far is this ridiculous number here, 2 to the power of 57,885,161 minus 1. Which, believe it or not, is 17,425,170 digits long. So if you don't mind, I'm not going to write that out here. Okay, so also remember that we can write numbers as a product of their prime factors, as in these examples here. We're going to use that to our advantage. Now every non-prime number can be written in this form, also very important. Now the method that we're going to use to prove this is called proof by contradiction. Now proof by contradiction is when you assume the opposite of what you're trying to prove, and you hope that you run into a contradiction, making that assumption invalid, thus proving what we want to prove. So let's get going. Now then, what we're going to assume, if we want to prove that there are an infinite number of primes, we're going to assume the opposite, that there's a finite number of primes. So there are only a certain amount of prime numbers. And what we're going to do, we're going to choose our biggest and our final prime to be this number p. And then what we're going to do, we're going to define a number x as all of our prime numbers multiplied together. So 2 times 3 times 5 times 7 times every single prime number up to and including p. And then we're also going to define a slightly bigger number, x plus 1, as that exact same number with 1 added on to the end of it. Now then, our new number, x plus 1, has two options. Either it is prime or it isn't prime. Same as any other number, they only have two options. So, option A, if it's prime, then already we've run into a problem, because it's not in our list of primes up to p. It's going to be far bigger than p, because it's p multiplied by every prime number below, and then with 1 added onto it. So already that's a little bit of a problem then, because it's not included in our so-called complete list of primes. Or we've got option B, which is that it's not prime. Now that might seem like a bit of a problem solution. It's all well and good though until we try and divide x plus 1 by one of our primes from our list. So let's take a look at that. So if we were to divide x by any of our prime numbers, 2, 3, 5, 7, any all the way up to including p, if we divide x by any of those, it will fit in exactly, because x is the multiple of all the primes. However, if we try and divide x plus 1 in the same way, then we're always going to get that remainder of 1 at the end. So what that means is that none of our prime factors from the list fits into x plus 1 exactly, which then tells us that prime factors of x plus 1 are missing from our list, or that x plus 1 is actually prime. Now this leads us to a contradiction. This tells us we don't have all our prime numbers written in the list up to p, and that contradiction leads us to the proof that there are an infinite number of primes. Now this was originally proven over 2,000 years ago by the Greek mathematician Euclid, who is also considered to be the father of geometry. So it's pretty cool. It's one of my favourites. Now remember that just because there's an infinite number of primes, that does not mean that there's the same number of prime numbers as there are numbers in general, because numbers are infinite as well. There are, believe it or not, different sized infinities, but that's a story for another day. So I hope you enjoyed the video, and thanks for watching. Don't forget to subscribe.